Hey, so today I'm going over the mini lesson on population trends. This is for you if you were not in class when we did this, or if you need some extra help. This helps you with Unit 2, Task 3. So, the main question that we're trying to answer in this mini lesson is why do populations grow and shrink? So, remember, a population is the sum of one species living in a set area at the same time. So, the example that we have here is if we measure the number of one specific species of bass in a lake in Iowa, we would say that it is a population of bass. If we look at all the humans that live in New York City, that is the human population of New York City. So, all populations have several traits that can be used to describe them. We have three right here. The first is size. This is the total number of organisms in the population. The next is density. This is the number of organisms divided by the total area or volume. For example, New York City has a very high population density because it's not a ton of space. It's not the biggest city ever, but there are a ton of people that live here. And so if we take the number of organisms or people and divide it by the total area, it's a pretty big number. And then dispersion, which is the placement of organisms within the region. So trying to figure out within one geographic location, where do the different organisms live? So population growth can basically be calculated by subtracting the number of deaths from the number of births. This gives you the net birth rate. If the growth rate is positive, that means the population is increasing. That means you have more births than deaths. If the growth rate is zero, that means the population is static. There's no change. The number of births exactly equals the number of deaths. If the population is negative, that means the population is decreasing. So the number of births is lower than the number of deaths. In Unit 2, Task 3 that you're working on, you're going to be calculating this for a set of populations. So, reproductive potential differs from species to species, and this also impacts how we think about population growth. So, for example, some bacteria have reproductive potential of as many as 19 million offspring. Humans, on the other hand, we can't have 19 million offspring. That's impossible. It takes us 9 months to even sometimes just have one child. So then we can think of, like, it has this example about whales. They could take a century to produce that many descendants. And so, how fast a population can have babies also impacts population growth. So, for example, reproductive potential is determined by the number of offspring produced at one time, the rate of reproduction, and the age of viable reproduction. So, if we think about humans, we can have anywhere from one, maybe 4 or 5 would be like the most we would see in a natural birth. That's how many babies we could have. Not super often, right? Because we need 9 months at least to keep the baby in the womb. And then we also have a limited age. Like after a certain age, females can't give birth anymore. So then we have limiting factors in populations as well. These are factors that oppose future population growth. There are two types: density dependent factors, which cause more deaths as population increases in density, and then density independent factors, which affect all populations equally regardless of density. So here we have some examples. So the density dependent factors would be scarcity of resources, so running out of resources that you need to survive, like food, water, or shelter. Disease, so a disease impacting a population and killing a large amount of that population. And predation. This is very important for the task. You want to know what predation is. It's when a natural predator to a species starts eating them and killing them, basically. Then we have density independent limiting factors, which are natural disasters like storms, weather, droughts, famine, things like that. Then we have adverse weather, so similar to natural disasters, and climate change is a big one. So those are the limiting factors. And population studies are really important because they monitor the health of various populations. So through population studies, we can anticipate if a given population is likely to grow or decline in the future. And remember, population has a big impact on ecosystems. And so it's super important that we understand how populations are doing because it impacts the entire ecosystem. So in the task that we're working on, Unit 2, Task 3, you guys are going to be studying different populations and analyzing different data. So go ahead and open that up and get started on Unit 2, Task 3.